Hey guys, in this video I want to talk about record types. Record types make it easy to create immutable reference types. In the previous video I talked about init-only properties and why they are great to make individual properties immutable. If you want to make the entire object immutable, you will find record types very interesting. Let's start with the creation of our first record. Let's say that we want to create a record for a leopard, and we want to create two properties for the leopard. The first one being of type int and being the amount of spots that a leopard has, and the second one for the amount of teeth that a leopard has. Now if we create a variable here and we do so for a cub, so we create a new leopard and we assign 50 for the amount of spots, and for the amount of teeth we provide 20. Now you might think just because a leopard is a record type that we are not able to update the properties. But if we try to do so, you will see that we can, and that is because the property contains a setter instead of the init keyword. To make properties within a record immutable, we have to change that. So let's change this to init for both the properties. And you will see that we are now no longer able to update the property. When dealing with immutable data, we want to make use of a technique named non-destructive mutation. And what this means is that once one or multiple values change, we create a new record that represents the state at that time. So let's remove this, and now let's say that the cub has become a 1-year-old. What we then do is, and let's say that once a leopard is 1-year-old, that the amount of spots that it has doubled compared to when it is a cub, and the amount of teeth remains the same. We can then call the cub variable and then provide the width keyword. And when we use the width expression, we can use an identical syntax to the object initializer and then change certain values. So like I said, the cub has 50 spots and 20 teeth. Now let's say that the amount of spots doubled. So a 1-year-old has 100 spots. And like I said, the amount of teeth remains the same. We can see if this works by printing both to the console. So let's print the cub and then let's print the 1-year-old. If we run this, we will see that the cub has 50 spots and 20 teeth, and the 1-year-old has 100 spots and 20 teeth. So the amount of spots we provided with the value 100, we did not touch the amount of teeth, so that remained the same. It's also possible to use inheritance with record types. So a leopard is an animal, so let's create a record for an animal. And let's say that an animal has a name. Again, we will change the setter to init. Now if we go back up and say that the cub was named Toby. Oh wait, we have to inherit it from the leopard. So the leopard is an animal, and then we specify the name, Toby. And once it became a 1-year-old, the amount of spots doubled to 100. Now let's say that once it became a 2-year-old, a rich person came by and decided to purchase the leopard. And he did not like the name Toby, but preferred the name Billy. We will again use the width expression. So in this case, it is a 2-year-old. And then we want to change the 1-year-old And this time we provide a name and change it to Billy. Again, we will write it to the console. And we will see that once it was a cub and once it was a 1-year-old, it was named Toby. And once it became a 2-year-old, it was renamed to Billy. And the amount of spots and amount of teeth is the same for the 2-year-old as it was for the 1-year-old. Let's make things a bit more interesting by storing a leopard within an animal. So let's say that we specifically state that 1-year-old is an animal. At this point, the compiler has no idea that 1-year-old is a leopard, so we will no longer be able to specify the amount of spots or amount of teeth for the 2-year-old. Still underwater, the entire object is cloned, and that is done by the hidden clone method that is part of record types. So if we execute the application, we will still see that the 2-year-old has a name, amount of spots, and amount of teeth. So regardless of the fact that the 1-year-old is explicitly stored in an animal class, underwater still a copy is made of the amount of spots and amount of teeth as well, which is as expected because we want to copy the entire object. Equality in record types is value-based. Now let's say that we create a new leopard that, let's name that Billy the second. And that is a new leopard, and that leopard has, let's see, what do we specify? 100 spots, 20 teeth, and it's named Billy. In this case, all the values are identical to the values of the 2-year-old. So let's print that 2-year-old equals Billy the second. And let's also print 2-year-old is the same as Billy the second. And if we run this, we will see that both statements return true. So that proves that equality is purely based on values. But what if we create a new record? Let's say that we create a record for a giraffe. And giraffe is also an animal. And a giraffe also has spots and teeth. So we create the same properties as we did for the leopard. And let's make a copy of this. And I will name this Ginny. And that's Ginny the first. And Ginny is a giraffe. And now what if we compare Ginny to Billy? I will only use a single line calling the equal statement. So Billy the second equals Ginny the first. So if the evaluation is purely based on the value of the properties, these two should be the same. So let's run it and see if they are. And we see that they are not. And the reason for this is because the types do not match. Each record has a property called equality contract, which is of type type. And this property must match alongside all properties in order for records to be equal. And we can see this if we go inside giraffe. Let's say that we create a method eat grass. If we then call this, we can see that it has an equality contract of type. Let's remove this again because we will not use it further on. Another part of records that I would like to address are positional records. They allow a more compact syntax to create record types. Let me show you by changing the animal record. So if we use positional records, we can remove this part and then provide the name like this. And what it automatically does underwater is create a property for name, and that will be a getter with init only properties. So exactly the way that we had it. If we do this for the base class, we will have to do the same thing for the classes that inherit from animal. So for leopard, we will provide amount of spots, amount of teeth, and also the name. And it will call animal, and we will provide the name. And the same thing goes for the giraffe. Simply copy this because they are identical. And what you will see is that we are no longer able to create instances of the records using the object initializer. So in my opinion, that's one of the drawbacks of using positional records. We can only do so using the constructor. So we would have to change this. And let's see, for the name we use Toby. The amount of spots were 50 and the amount of teeth were 20. Let's copy this and do the same for this leopard. And this one was named Billy. It had 100 spots and 20 teeth. And also the same for the giraffe, and we can copy this part. And let's remove the D. And now if we run the application again, we will see that everything is identical to what it was before. But as you can see, the records are way more compact than they were. So the positive part is the fact that everything is so compact, but the drawback is that we are forced to use a constructor. And that would prevent me at this point from using positional records unless unless the records have very few properties like they do in the records that we see here. So in that case, I wouldn't mind using the constructor, but let's say that we have a response from an API containing 20 properties, then I would not want to use a constructor. And in that scenario, I would not use the positional records. Another part of positional records that I would like to show is the deconstruct. And that allows us to assign the values of all the properties to variables. And we can easily do that by specifying variables for the properties. So we provide a name, amount of spots, and amount of teeth. And we can then simply say is Ginny the first. And now name should be Billy, amount of spots should be 100, and amount of teeth should be 20. So if we print the variables to the console, name, amount of spots, and amount of teeth, we see that they match with the properties of Ginny the First. The last part that I would like to discuss is the toString implementation of record types. Records contain a protected method named printMembers that takes a string builder as argument. The property names and values of the record are then appended to the string builder. The toString method itself calls the printMembers method and surrounds the output by curly braces. We already saw this when we ran the application before, so let's do that again. And what you see here on this line, so the name is Toby, amount of spots is 50 and amount of teeth is 20. That is the output of the printMembers method. And what the toString method itself does is provide the name of the record and surround it by curly braces. In my opinion, record types are a great addition to C#. I can see myself using them for input and response models. I'm also curious to find out about the use cases that you guys see for record types, so make sure to share them in the comment section below. If you enjoyed the video, make sure to like it and to subscribe to the channel. Thanks for watching and see you in the next video.